how does that look? Yeah. Graphs are one way to store data. It's a type of knowledge representation. If you have a bunch of data, you have to represent it in the computer some way. And graphs are a good way. And this is an AI topic, okay? So these knowledge graphs are a component of AI. So if you're going to have an AI, AI is going to be reasoning, talking about some kind of data, so you have to store the data some way. And I think probably the best way right now, the most intelligent way, is in a graph. So I just downloaded some of these graphs off the internet. You can find these yourself. And this is, when they display these things in 2D, this is called layout. And you can lay out the data, the graph, any way you want to. And sometimes it's strange or beautiful. And there's a company called Tableau you guys might have heard of. They have, that's probably the number one right now, visualization software. They have great software that allow you to visualize. Even in 3D, you can go into virtual reality and look at your data in 3D. But of course, these graphs are not really three-dimensional, they're highly dimensional. So, I mean, say they're 100-dimensional. So if I'm gonna look at it in 2D, then I'm gonna be flattening it out somehow. They get very large. I mean, you can find some graphs. I mean, there's millions or even there's some knowledge graphs that have hundreds of millions of triples in there, so they can get very large. And this is a social graph right here I found. And I'm guessing that this is a company the guy works for now. Some guy did this. These are like two older companies. I guess this is college over here. Maybe that's his family, and these are just some people random people. So he organized it from Facebook or something and put their faces on there. So that's also a graph, and that's very interesting. Yeah. Tableau. It's expensive, I think. Yeah. I think it got started as being a visualization, but you know how software grows over time, right? It gets bigger and bigger. And yes, but one of the parts of it is you can visualize your data in a good way. And they have a meetup here in this area. It's fairly popular, but companies like Capital One, big financial companies, would be the ones that would be interested in that more than I would say the federal government. So I work for the federal government, so they would have some interest. Okay, these graphs are made of triples. There's a subject, a predicate, and an object. Both the subject and object are nouns. Well, the predicate here is like an adjective. And think of it as three numbers. So these triples are what the graphs are made out of. They're very simple, but I think of a triple as a quanta, I used to be in physics, as a quanta of information. All right? And here's another way of looking at it. Here's an example of a triple. John has manager Ken. So that's a piece of knowledge, right? It's like a quanta of knowledge. So from these, you can build up a knowledge graph, and you can describe, you could say make a knowledge graph describing, say, the Battle of Gettysburg or something. And it might have thousands of triples in it, right? All the armies involved and generals and so forth. So this from those triples, this slide right here shows how I can start to build up a larger graph. So each one of these three pieces right here, 1, 2, 3 is a triple, and 1, 2, 3 is a triple. So these triples connect up, and that makes a graph. Usually these graphs don't have loops in them. I'm not aware that they have loops. RDF is a standard from the 90s. I don't know if you guys ever heard of RDF. There's a lot of RDF databases. This is called triple store or triple database. And they're obviously indexed, and they're fast, and some of them you can store billions of triples in there. RDF is a standard. And people use it. I mean, I've never worked for a company that had an RDF database, but they do have customers. You can go out there and see that people have been using them for putting data in there. So this is where you would store your graph, say, in an RDF database. All right. So how you build it, you can put any kind of data into the graph from your databases, from files. You could take things like emails, any data you have eventually, because emails are connected up to a person, right? You have, say you're talking about a product or something. You can connect it up to the graph. So any kind of data can be connected up into these graphs. Now this is a giant knowledge graph that's owned by Google. So I have to connect this talk to Google. Freebase, I think Freebase now is approaching 1 billion triples in it. It's a knowledge graph. It describes like everything. There's schemas in there. So they have graphs in there that describe cell phones and what you would do on a cell phone, and a lot of things that are of interest to Google, which is, a consumer company. It's not so much abstract. It's really kind of real. So that was really good. I don't really think there was a really good application of knowledge graphs that I could name until 2011. All right. 2011, this program called IBM Watson. I was amazed by it because I've been in an AI group, and we talk a lot about narrow AIs. Google has a lot of AIs. Most AIs are narrow, which means they have a very small specific purpose, playing chess or something, even though they're very good. All right. They're still narrow. I would say that Google's search algorithm is probably the largest AI in the world, and it's not really that narrow. It's pretty wide, right? You can search anything. So it's a big thing. Well, IBM Watson came out there and crushed the two best players. Those two guys, on the east side, are the two best players in Jeopardy in the world. And Watson, the first time it went out, crushed them. I don't want to go over the details, but underneath all this is a knowledge graph that uses everything Wikipedia. I mean, they took the entire Wikipedia database and crawled it and turned it into a graph. And they also add CIA fact book and some other data in there. Wikipedia is about history mostly. Have you guys ever looked at Wikipedia? It's mostly like the history of the Vatican, the history of Soviet Union, and they'll have pages and pages. So it's, and that's what Jeopardy is about, really. Jeopardy, most of the questions in Jeopardy are about history, right? If you think about it. So that's IBM Watson. What does that say there? Yeah, it's a history quiz. IBM Watson 1. I was amazed. This is a big program. They put together a huge data center to do this, and the Watson could not be connected to the internet during the contest, so it already downloaded. And each one of the computers on each server, they have the whole database, the Wikipedia and everything, the knowledge graph again and again and again. And what they're going to do, they're going to scale out. So the query comes in to IBM Watson, and it very quickly, say, produces 10,000 answers, all right? 10,000 of the best answers to things. Then they split these 10,000 answers, like chunks of 100 to 100 different servers. And those servers think. They go through these several layers of process. I'll have a slide on that. And they think about the answers. And they eventually come up with a score, and they come up with a score of the best answer that they think is the best answer for the Jeopardy question. And if they have a probability of confidence on it, and if the confidence is above a certain level, I think it was about 0.75. If the confidence was above 0.75, IBM Watson would actually hit the button. They had like a little motor thing there, all right? And then it would answer. And Watson didn't, some questions it couldn't figure out, and it didn't try to answer. Others, it tried to answer and got it wrong. But it beat the two best players in the world. This is another version of their data center. So right now it's expensive to do this, but think about it. Someday, I don't know how many years, all this is going to run on your phone or whatever, right? They end up getting this to run on mobile devices. so that would, Yeah, it'll be a much improved algorithm, and it'll be more intelligent, right? But it won't be the same code, I'm saying. But
the scaling is going to go on. They have the scaling, they have the Watsons running, where they're doing the things now in the medical world.
Yes. Yeah, I'll talk about that a little bit. I don't really have a slide about the medical. That's where this talk is not so much about Watson, but Watson would be the best example. But I mean, we had a delay. I was going to run Google Now, which I like the best. Siri's, okay, if you run Google Now and Siri, you kind of feel like Siri's kind of dumb. It's like it didn't go to school or something. But I actually have a slide on that. Okay, so when they won Jeopardy, I was surprised because this contest, winning Jeopardy, is it's a general intelligence. It's not narrow. Jeopardy they asked questions about a huge variety of topics. So things are changing in the world. AIs are getting bigger. Now there's a bunch of competition, right? There's a bunch of these programs. I put DuckDuckGo down. I'm not actually sure what DuckDuckGo does, but I think it has an API that lets you do some of this type of work. But he mentioned Wolfram Alpha, Siri. Microsoft has a good one. And Amazon Echo, which the speechwriter talked about that. I read a review when it first came out. It was not very good, but then it got much better right away. So I'm hearing that Amazon Echo is, but you have to buy your own little computer. It's like a cylinder, which is, it's okay. I think I actually might get an Echo to put at my house. It's such a cool technology. Okay, obviously Google is an AI company. The Google search is a giant AI. Now, knowledge graphs were added years ago. Google came up with a knowledge graph program, and the knowledge graph is embedded into many Google products, all right? And I read somewhere that Google now basically is a query into the knowledge graph, whereas Google search uses the knowledge graphs to add semantics or meaning. So if I search, like I'd like to buy a SUV, it knows that you're talking about a vehicle, or it knows that you might be talking about a truck. So it has more meaning. Whereas before they added these kind of knowledge graphs, it didn't have that kind of deeper understanding of what you're saying. So it's semantics, meaning. So the knowledge graph adds meaning to the search, and it's integrated in with it somehow. And Google doesn't give you any details of how they do that. But Bing does the same thing, and they have a knowledge graph called Sortana. Does anybody know the name of it? Sorry, they bought a company or something. So Bing also has a knowledge graph embedded in their search. Yeah, something like that. Well, that's Microsoft Cortana, but the Bing search stuff has another technology, which is the knowledge graph S something, I don't know. So it's in there. Okay, so how does this work, all right? So we've got our knowledge. We say we have Wikipedia, which is obviously that would make a very large knowledge graph. And how does that graph produce the smartest machine on earth that the world's ever seen? So the next slide is a good one. How did this happen? How did we get here? Huh? Yeah, internet comes from this. These are right down the road, in Arlington, DARPA. So, I went to the moonshot. Did you guys go to the moon? I went to the moonshot talk. And I'm not saying DARPA is a moonshot because it's defense related, but DARPA says they don't really work on anything unless everybody says it's impossible. So if people say if they propose something and people say, oh, I know how we'll do that, well, then they won't do it. So in 2003, they had a project called Chalo. Okay, the Chalo means cognitive assistant that learns and organizes. And it was a competitive project. And the winner in this contest was SRI, Southwest Research. And they created a program which you can still, it's at pal.sri.com, I think, PAL. PAL is it means that it learns, okay? And you can actually, I just looked at it, I was looking a while ago, you can still download it. It's about 10 different files you download, and it would take a lot of work and an expert to get this thing. It's not a single program that you can download and use. So if you wanted to make one of these yourself, one place you could go to SRI and download PAL, and you'd have to figure out how it works. And there's like 9 components to it. But they have some help files and so forth. Okay, also I went a little bit, I tried to find out what the technology is behind Watson. And like I said before, when they get a question in, they do a query, and they want to get a bunch of answers, like thousands. And then they split those off into various machines, and they have a bunch of other AIs. Now this is the thinking, this is the cognitive computing part. There's intelligence, a lot of intelligence embedded in the graph itself. Just like an index on a database, it has intelligence in there. But there's more intelligence. Once they get the rows, they have these cognitive units that think about it. And they don't give any details how these things work. But I think they're probably related to the DARPA Chalo technology, plus some added stuff that IBM put in there. IBM is actually selling this, IBM Watson. They have a developer program right now, and he mentioned the health. They're pretty positive they're going to be able to get some business. They put $1 billion into Watson, and they have a pretty big crew. And there's a bunch of different applications. If you go to their website, you can actually, if you come up with a good idea, they will actually, you have to have a good idea. They'll let you use it. So you load up your data and files out there to their servers. Watson will create the knowledge graph, and then you'll see how well it works. You don't get to download Watson. It's proprietary. So what IBM is intending to sell as a service is this question answering thing, or basically they're selling intelligence. So when you do a health application on Watson, you're asking questions like, my head hurts, what pill should I could take? That takes intelligence. I mean, you're prescribing a drug. So what they're selling is a service which is just basically intelligence in whatever your domain. So you could say be in the mortgage business, and you load up a bunch of files, everything you know about mortgages. And so now you can have online, you can have on your website, you can have an intelligent service from Watson that answers people's questions about refinancing, whatever you have, mortgages, et cetera. Here's another file I found about, this is a file that IBM gave us about how the knowledge graph is built. It's pretty complicated. this is this is pretty complicated. Watson's. I'm not saying it's simple. They had hundreds of PhDs working on this, so it was a big deal. Okay, so how do I do this myself, right? So I have a client, or I have a pie in the sky. Actually, people I work for right now, which is the Army, they actually, I was in a meeting, they were talking about this, and they want to add question answering or a natural language interface to their software. And they didn't ask me for my opinion, but the technology does not exist. I was going to tell them that. So I don't know. Somehow they all thought that, oh, we could just put a bunch of phrases in an if statement or something, and it would be. But it's like it's like people tried that like in the '60s, but now there's hope. Some pretty smart people put together. I think they went back to that SRI PAL program and some other programs, and they also added vision, and they put together this open source project called Sirius. So if you're interested, you can make a knowledge graph, but it doesn't do anything, right? You need the cognitive part on top of it. That's what Sirius is. And Sirius does, this program here I'm going to show you, it includes a knowledge graph, which is 11 gigabytes compressed. You have to download it. So I don't think you can run this on your phone, but you can definitely run it on a Linux server. But the graph itself is very large. It's going to be indexed, but it contains all of Wikipedia in there. And I think the CIA fact book, which is about countries. So what else do we have? Okay, so how this thing works. Clarity Lab is the name of the company. It's one of these small open source companies. The last guy was talking about Mapbox. That's also an open source company. So Clarity Lab's an open source company. I don't know how many employees they have, but they're in charge of this. This Sirius software is, it's not going to be that easy to use right now. You'd have to be an expert in Linux programming to get it to work. It's not an easy download. But if you did get it to work, you could add your own graphs to the knowledge graph. And so now the Sirius program would be able to answer questions about your domain. And it could be anything. I mean, like it could be working for the Veterans Administration. You could ask questions about veteran care or something. Put that in there. So this is a little graphic I've found about basically how it works. It has speech recognition. It has text recognition. And it also does image recognition, which is very interesting. So you can put up if it had a camera, you can put up a photo of something, and the Sirius program will attempt to answer questions about the photograph. This, answering questions about digital photographs right at this time is state-of-the-art AI. There's conferences and contests going on right now. They've recently made some huge gains in this using deep learning, which I'm not going to talk about here. I don't think Sirius uses any deep learning at all. There's a little blurb there about the Sirius program is a lot of different AI servers and programs that have been integrated together. So it's a big deal. So that's, think about, my interest is that, I'd like to be able to at least think about doing this myself. And now there is hope. I mean, you have to learn how to use a Sirius program. Probably in 2 or 3 years, this will be a lot easier to use. It's on GitHub, and people are working on it. And I get the emails from it. There's a lot of people struggling with this program right now. So this is how you would do a question answering system on top of a knowledge graph right now in 2015, if you want to do it yourself. Or you could use Watson. So I guess that's it. I'm hoping that somebody here in the audience is a much better expert than I am about this topic. So these last 2 slides are a joke. So once we get all this working, and you have your Google Nest, and it's a have a Google Nest, and so you're like working someday, and you get a text, and it says, "Hi Bob, this is your house," and your house texts you. Because I was just talking to a guy outside he's totally wired up his house with a computer, the home automation, and so you get this text, "Hi Bob, this is your house." Questions?
Well, Vint Cerf had something almost like this, because he built something that handled the sensors inside his wine cellar in his house that would send him a text when things got out of the level of range where it would be dangerous to wine people. That's about 12 years ago.
I've heard of that guy. I like that guy. He's got a wine cellar. Yeah, I don't have that level of money yet. But any questions? Yes.
Are you seeing? One of the areas is some of the advances in an extremely broad system that one feeds information into that does a learning process to create the graph rather than human creating graphs. There appear to be other avenues that people are looking at particular domains sets of domains to be able to infer, natural language.
There's another part, yeah.
Which areas?
Well, there's another part of Watson I didn't talk about in that they've loaded up millions of conversational, like a corpus or a corpy, like question answers, okay? They're not the same question answers that you're going to ask. It's not an exact match, but they include into that like 1 million of these question answer pairs, and the Watson system processes it to learn the basic natural language of question and answers, so it can form the natural language. So he asked about if you do your own domain. Even if you did a domain about mortgages or something that you think is small, unless you have a pretty big, wide knowledge base, it's not going to work. I mean, people have tried this. It's like it will seem stupid. See, what people like about their phones, those people staring at their phones all the time. And why are they doing that? Well, it's intelligence. I mean, it's whether it's Instagram or you're going on to Twitter or you're watching a video, you're experiencing intelligence. And it's not easy to achieve, but it's getting there now with this program we're talking about. So that's what people like. So a lot of people criticize it. They think it's bad because you could go in the metro, everybody's staring at their phone. And sometimes I've actually been talking to people, and they'll pull out a phone in the conversation because at that moment, what's on their phone is more intelligent than me. Okay? And it's like, don't be so intelligence is going to get into everything, and it's going to come pretty fast. And I just reading some stuff recently, and some of the big tech writers and thinkers they're saying in 2 or 3 years. Oh, it's the guy that runs Under Armour. He says in 2 or 3 years, everything you buy is going to be intelligent. They're going to be chipping everything. So you asked me about the domain. IBM Watson is working on that. Obviously, multiple domains. It's not easy. So if you're going to set up Sirius for yourself, obviously you want to do it for whatever your domain you're interested in. In my case, it's the Army, so it's like Army stuff, right? Right. Move the helicopter over there.
That's only one part of the Army, because the Army is learning that the world is different than what it was 10 years ago, 20 years ago.
The Army's changing very rapidly. I'm watching it. They're becoming very high-tech and computerized. And they're also shrinking. They don't need as many people for what they're doing. But so I guess it went dark. And so the thing is, the point of this talk is that using knowledge graphs, this question answering or natural language technology is becoming possible now. And so you will probably soon see products that we have it on Siri, we have it on Google now, and the big companies have got it working. And it's going to spread out, and then it'll go into the middle-sized companies, and everybody will have it. Then you'll be buying a pair of tennis shoes, and it will talk to you. I'm not kidding you. It will talk to you and say, does it fit good, or how was your run?
Most of the examples you talked about are to do with bodies of knowledge, reference,
Mm-hmm.
like the Wikipedia. Do you know what kind of developments there are when it's like a moving body of knowledge, like watching a football game or in the weather or whatever, where you got the changing facts?
Again, I would refer you to, there's some pages in IBM Watson where they take the questions that people are asking. This is not the Jeopardy application, but another one. And I told you about how they take question answer pairs and they train the system just to learn about the English language or whatever language is in. They also take real recent questions and they process it to improve the system. So they're doing that now. They need to use what's happening in, like, say, in the last week to improve, because otherwise it would seem stale. It's just like take your Google search, all right? Google makes more than 500 tweaks to that algorithm per year, all right? You don't notice, you just use it. It always seems to work great. But if they stopped doing that for like 1 year, you would notice after a year that it was getting stale. You might look for another solution. So the big companies are doing this. They keep things updated. And I think that what you talk about is state of the art. You want to we were just talking about that. I mean, it wouldn't be great if, like on NFL.com or whatever, college football, I could sit there and talk to a conversational computer during the game and ask, like, oh, that guy that just scored a touchdown, where was he born? Where is he from, right? And it's not there yet, but it'll probably be there. Probably NFL will have it. I mean, they have the funding to get this done.
The NHL had one of those apps, but it was about the end that they were running on glass
Okay.
about a year ago.
Okay.
But as you generalize the area you're describing, you've got some of the AI areas that are looking to provide neural network interfaces as a means to get information in, to put something there so there can be some discovery that occurs in this area rather than just regurgitation of man-made information. They run some interesting areas
Yeah.
in discovering things. They've discovered some of the same things that humans have discovered some other possibilities that we looked at, but we should look down that avenue. We hadn't looked down that avenue.
Do you work in AI? Are you a professor? Okay. I mean, getting asked about fresh information. I mean, the free base and the big knowledge graphs are going to have the definition of a person, right? But you know, the new information would be a particular person. Like I just met this gentleman here, and you know, like you put it in your context. But I'll put it in the knowledge graph. I'll put his name and what I know about him. He was at this conference. He's obviously interested in technology, and you'll build out a knowledge graph of him based on person. So I know that he's not a table. He's alive, and you know the type that he is, as opposed to another type. So you will always be adding new information to the knowledge graph. That when you get it, if you get it up and running, that's what the customer's going to want. The most interesting data is the stuff people just uploaded immediately. We have that problem all the time because we have large data sets where I work, and the customer wants to see the data that was loaded 5 minutes ago. And it's like sometimes that's not possible because it takes too many CPU cycles, but that's what they want. So yeah, once you get the system where you can build a knowledge graphs, if you can add new data, then you can just add new data every hour and keep it updated. But again, this is not easy. It probably costs, to actually get this working, even in anywhere, it probably costs millions of dollars of development per time. Yes?
In the 80s, I remember there was some Mycene experiments at Stanford.
The blood stuff?
No, it was antibiotic. I'm not sure. But I don't know what happened to that. I remember some of the earliest AI was Stanford.
Well, this guy Winograd, who was the teacher, the graduate student teacher to Sergey Brin and Larry Page of Google, he's an expert in natural language, and search is a part of natural language. He wrote a program like in the 60s or 70s in Lisp. It was called Block's World, and it was really good. And you could sit there and say, is the red block on top of the blue? It worked great, and people were really excited. But it could talk about 3 blocks. And then some graduate student tried to, okay, I want to try to extend it to 4 blocks or n blocks, and then it didn't work. And it didn't scale. So I don't think we really got this kind of natural language capability until very recently, 2011. I think that's when I first noticed it came out. And do other people secretly have it somewhere? I don't know. I doubt it. But I think Watson will probably get some of these into production. I think they're experimental right now, trying to see which one. A lot of these things you try to set up these knowledge graphs or whatever, and they're just not useful, or the customer just doesn't see them having a value. Obviously, if you're a company, you want to sell something, you want to use it to help you sell something. Yeah, but the people I work for, they want this natural language interface because they're lazy. They don't want to click on the computer. Yes. I know some of them want to do it in the office, and it's like, yeah, okay. I mean, the customer's always right. So, I mean, literally, they came in and say, we're tired of clicking on all these boxes all the time.
Well, that's a simple, doing some natural language, to map that to keyboard form selection is a small problem, but to get what you really want.
Yeah. Yeah, I mean, but what they want to do is they want to, they interact with all kinds of IT programs and so forth, and they want to interact with all those in an automated way, and that's a hard problem. Obviously, email is the basic of it, but they have a lot of software that they use, and growing all the time. Each soldier is becoming a little data center. They can have up to 10 computers, and many of them are networked, and that's kind of a really active thing around. The DoD the Congress just gave them like $7 billion to increase network access on the battlefield. And one way they do this is they have a drone which has kind of on its belly a radio gizmo, and so then it gives LTE, like cell phone LTE, because they want to use off the shelf, so it'll provide an LTE signal, which will be just for a small period of time during that whatever they're doing, and so it allows the guys on the ground to use other computers. Plus the commanders, they want data like real time uploaded. They want to see what's going on. It's not like your dad's army.
With frequency shifting.
Yeah, yeah, they have all that.
And depressing the quote enemies of the same thing.
I know in the Civil War, the Battle of Spotsylvania, the Union lost an entire army one day. The general sent off an army to do something, and then the next day he hadn't heard back from it. So he sent another army to find it and found out that they had actually lost their life. But nowadays they want to know every time your gun goes off. They want to know where you're pointing the gun at. It's like they're micromanaging things. So, I mean, I guess that's a good thing. Oh, yeah. You know, it depends on your perspective. Computers are wiping out people's jobs. They have been ever since the 80s. So if you become unemployed and become homeless, then the computer's been pretty bad to you, right? And so now they think they're going to get even worse and actually kill us, probably. Even if they can stop it in this country, another country will make such a thing, a drone. I mean, all you have to do is take I have a quadcopter, I have a couple. Take a quadcopter and stick a grenade on it, all right? That's a pretty nasty device. Well, there's websites that say the world's going to end on the 23rd of this month, which is how many days away? Yeah. And I look at some of that stuff. I mean, they've said that stuff before. I don't know. So, yeah. I think that's, you know, and the drones are obviously, and all the computers are ruining our privacy, so I can't really be that optimistic. Do I think that somebody will come up with a really smart robot that will kill people? Yes. I think they already have such things, but I don't know. I mean, we already have a big problem with drones at airports. I think people like to, I don't know why, maybe it's because it's open space, they like to fly drones around airports. And you keep hearing about this, right? And the airplane pilots are really alarmed by it. So if one of those things brought down an airliner, that would be bad. They would no longer let you buy drones in Target. They're waiting for something like that to happen. But yeah, you know, these Watson computers, these aren't like a human at all. The knowledge graph, it has similarities to some of the ways. I mean, we can understand the knowledge graph, and that's the whole point. Thing like XML. Knowledge graph is the computer understands it, and we understand it. So it's in that crossover. So that's why we like it. But that doesn't mean the computer works like the human mind does, and it's not even near that level yet. But just to make a weapon, it doesn't have to really be that smart. I mean, look at a mosquito. Right, it can wreak havoc, and it. Look at the cars and parking. Yeah, we're getting those too. I feel bad who had those people who had those driving jobs. That's another thing. Did you know in most states in this country, the #1 job description is driver, and then Google is going to get rid of drivers. So what are all those people going to do?
Well, they might still be alive.
They'll all become app developers, and they'll use Firebase. All right, is that it?